world of naval supremacy, submarines reign as crown jewels of any formidable fleet. China's navy continues to expand its foothold, challenging rivals in the contested waters of the South China Sea.
China has suffered a significant blow to its naval ambitions. Its most advanced nuclear-powered attack submarine,
Imagine the ocean, endless, deep, dark, and quiet. But beneath the waves, silent giants move. Submarines slip through water like shadows, invisible, undetectable, and deadly. Now imagine if all these stealthy undersea giants could suddenly be seen. What would happen to navies around the world? Could they lose the advantage that submarines have had for decades? This is exactly what China's new submarine detection technology threatens to do. And yes, it could change everything. Let's start with something most people don't know. Submarines are designed to hide. They are covered with special tiles, engines are muffled, and movements are calculated to avoid detection. For years, sonar was the best way to find them, but it has limits. Especially in shallow waters like the Taiwan Strait, sound waves bounce, scatter, and fade away, leaving submarines almost invisible. Traditional sonar cannot always detect them, but China has a new plan, a plan that could make hiding underwater nearly impossible. Magnetic wake technology. China's first breakthrough comes from the discovery of magnetic wakes. Submarines are made of metal. They move through water, and that movement disturbs tiny particles and ions in the ocean. These disturbances interact with Earth's magnetic field, leaving faint magnetic trails. Researchers at Northwestern Polytechnical University in Xi'an found ways to detect these trails. They use airborne magnetometers that can sense even the smallest shifts in magnetic fields. Think of it as following invisible footprints left in the sand, except the sand is the ocean, and the footprints are magnetic. This technology is revolutionary. It means submarines leave traces that cannot be silenced or hidden. Drone-mounted quantum sensors. Next comes the drone-mounted quantum sensors. Led by Wang Shuifeng at the Quantum Engineering Research Center of China Aerospace Science and Technology Corporation, scientists created sensors that detect tiny magnetic changes using quantum physics. They use rubidium atoms that react to magnetic fields in ways normal sensors cannot. These atomic magnetometers generate signals that can map magnetic fields accurately. Offshore trials in Shandong province showed the system could detect extremely weak signals, down to fractions of a billionth of a Tesla. That's almost unimaginable sensitivity. By attaching these sensors to drones, China can cover large areas quickly, detect submarines in low-latitude regions where magnetic fields are tricky, and get results cheaper and simpler than existing NATO systems. Electromagnetic detectors. Here's the next piece of the puzzle: electromagnetic detection from the seabed. Scientists at Shanghai Jiaotong University designed a truck-sized system that monitors low-frequency electromagnetic waves from submarines. Instead of relying on sound waves in water, which fade quickly, this technology tracks electromagnetic waves traveling through the seabed and rocks. Waves move farther in rock than water, so submarines can be detected at longer ranges. Using sophisticated algorithms, the system can distinguish between submarines and natural sea signals. Tests have already detected surface ships nearly 2 miles away, and researchers claim the system could one day detect submarines over 31 miles away. If true, this could force U.S. submarines to stay far from contested waters, changing the rules of naval strategy in areas like the South China Sea and Taiwan Strait. Terahertz-based sensors. But wait, China is not stopping there. They are exploring terahertz-based sensors. These devices detect tiny ripples on the water's surface caused by submarines moving below. Terahertz waves are extremely high frequency and sensitive, able to measure vibrations just 10 nanometers tall. These sensors, combined with advanced algorithms, can pick out submarine movement from natural ocean waves. Tests show they can spot ripples in harsh sea conditions, making them a potential game changer. Terahertz sensors could even enable communication between submarines and friendly aircraft, something previously very difficult. Sonar system. To keep the flow going, China is also enhancing underwater acoustic detection. Researchers at Harbin Engineering University have developed a passive sonar system that can find submarines in challenging Arctic conditions. Using the natural layering of water in the Beaufort Sea, the system tracks low-frequency sounds and determines the exact depth of targets. They claim near-perfect accuracy in simulations. Unlike active sonar, which broadcasts sound and reveals the location of the searching vessel, passive sonar listens silently. This technology allows China to detect submarines in icy waters where traditional sonar struggles. Underwater Great Wall. And the shocking part, China is combining all these technologies into what they call the Underwater Great Wall. Magnetic wakes, quantum sensors, seabed electromagnetic detection, terahertz waves, passive sonar layered together. They create a net almost impossible for submarines to slip through. Imagine a US nuclear submarine trying to hide while every movement leaves traces in multiple forms: magnetic, electromagnetic, acoustic, and even subtle surface ripples. Every path can be tracked. Every secret route could be compromised. The stakes are sky high. If these systems work together in real-world conditions, the balance of power under the sea could shift dramatically. Let's take a moment to understand the implications. Submarines are traditionally a country's secret weapon. They can move undetected, launch missiles, and control vital sea lanes. If China can detect them reliably, the United States, Japan, and other allies would have to rethink naval strategies. Submarines might need new designs with advanced magnetic cloaking or stealth technology. They could use decoys, unmanned underwater vehicles, or new movement tactics to evade detection. The game is changing, and the clock is ticking. Laser technology. But that's not all. China is also experimenting with laser satellites and sensor balloons. These high-tech tools can monitor the ocean surface and track wakes from submarines. Satellites could detect vessels operating 525 feet underwater, while sensor balloons hover silently, monitoring traffic over wide areas. Combined with the other technologies, China could maintain near-total awareness of underwater activity in strategic regions. Squids. And it doesn't stop there. Superconducting quantum interference devices, or SQUIDs, could further boost magnetic detection capabilities. These devices can measure incredibly weak magnetic fields, potentially making stealth submarines almost completely visible. While China does not have operational squid-based detection yet, research suggests it could be part of future deployments. This is like adding night vision to an already perfect security camera. The level of detail that could be captured would be extraordinary. Now, for a real-world perspective, imagine a logistics ship carrying fuel or supplies in contested waters. Normally, it relies on submarines for protection, but with these Chinese detection systems, enemy submarines could be found before they strike. The fuel ship becomes vulnerable. If hit, it could erupt into a massive fireball. The stakes are not abstract. They affect civilian crews, engineers, sailors, and strategic supply lines. These technologies are designed to make stealth, surprise, and secrecy almost impossible. Impact and future ahead. China's strategy also shows the growing integration of military research and civilian technology. Universities, research institutes, and the military collaborate closely, sharing discoveries and building on each other's work. Terahertz sensors, quantum magnetometers, and seabed EM detectors are tested in real-world conditions, ensuring that theoretical breakthroughs become practical tools. By connecting civilian science to military applications, China accelerates its technological advantage. Do you know that the quantum sensors attached to drones have demonstrated a detection accuracy correlation of 99.8% across multiple test runs? This means the system reliably spots the same targets repeatedly, reducing uncertainty. Reliability and consistency are key in military operations. One false positive or missed detection could mean disaster. China's emphasis on repeatable, verifiable results suggests they are serious about operational readiness. So, every time we explore one detection technology, another emerges. Magnetic wakes lead to quantum sensors, which lead to seabed EM detection, then terahertz ripples, passive sonar, satellites, balloons, and SQUIDS. Each layer adds complexity and makes submarines more detectable. As each question is answered, a new one appears. How deep can submarines hide? Can stealth materials survive these sensors? What happens when all these systems are combined? The suspense keeps building. So, are we ready? Can global navies adapt to this rapidly changing landscape? Will new stealth technologies counter China's detection systems? Will undersea warfare become a new chessboard where one wrong move could be catastrophic? The answers are not yet clear, but one thing is certain. The war on the horizon may look very different from anything we have seen before. If you found this video eye-opening, make sure to hit that like button and subscribe for more updates on cutting-edge tech and military breakthroughs.